Up next, we're talking about focal length, more about depth of field with aperture, and maybe a little bit of lighting. So let's start with focal length. Let me see if I can wrap my head around all this. The simple thing, focal length in millimeters based on the lens you have, whether it's a prime lens which doesn't have the ability to zoom or a zoom lens which has multiple focal lengths, is the distance from the camera sensor to the point where the entrance beams converge. So if you've ever seen an example of an eye, there's going to be a lot of eye examples in this, it's a camera. When they demonstrate the beams of light or the picture or the object coming towards the eye, the curvature of the eye, the lens bends the image, bends those beams towards each other until they cross, and then they cross each other onto the retina upside down. It's the same thing happening with the sensor. So the distance in millimeters from that convergence point where they cross to the sensor is your focal length. Now, at least for me in my head, it seems intuitive that this would happen, but as the focal length increases, if the focal length increases, the distance from the convergence point to the sensor is going to get longer based on the definition, which would mean that that angle that exists between the points where the point converges and the beams start to separate towards the sensor, that angle is going to become more acute. It's going to become smaller, which means in the other direction, the angle is also smaller. So a wide angle lens would have a beam like that, and a zoom lens or a telephoto lens would have a beam closer to that. Or as you zoom, the wide angle starts to narrow. That all makes sense. That narrowing of those beams and that angle is what makes up your field of view. And so as we've seen in the demonstration, when you use a wide angle lens like this 16 millimeter, you're going to get a much greater landscape, so to speak. And then as you use something closer to a telephoto, when you start going from 16 and you start going towards 70 or 200 or even further millimeters, you're getting less real estate in the image, but in exchange, you're getting the ability to zoom. You're getting the ability to get a more telescopic shot. Now with aperture, this gave some clarity to what the f-stop actually is, because as we've mentioned before, the f-stop is sort of inversely related to the amount of light coming in. Or to put it this way, the number of the f-stop is inversely related to the size of the pupil, right? So as the aperture opens up, the aperture number of the f-stop is dropping. What they also mentioned, which we mentioned back when we talked about the exposure triangle, is that as you open up the f-stop, you're actually decreasing the depth of field. You're making the depth of field more shallow, which means you're going to have a much narrower focus point. And because it's narrower, every single thing before and after that focal point is going to be blurred. And so inversely, if you want things in the far background or up close, if you want everything to be in focus, like if you're taking a huge landscape photo or video image, the more you want in focus, the more closed you want in your aperture. Now here's where things start to get a little bit confusing. What they mentioned in the class is that your depth of field decreases as your focal length goes up. And the only way they showed that was by demonstrating that if you take a picture of something with a wide angle lens, you get a certain blur in the background, but then when you take that same picture, you swap it for a telephoto lens, it zooms in, and the background is far blurrier. I might be understanding this incorrectly, but we know that widening the aperture, opening the aperture up, will decrease your depth of field and make it more shallow and make things blurrier. We also know that the beams that come into any lens, whether it's a telephoto lens or a wide-angle lens, are diagonal beams that converge and then diverge to hit the sensor. If you open up the aperture of a lens, then intuitively, you should be getting farther apart beams converging, which means the angle should get wider. It should look more like a wide angle lens. So like, for example, if you have a telephoto lens, like a 70 millimeter or a 50 millimeter lens, and that has a certain angle of convergence, if you widen the aperture, it may not necessarily become the equivalent of a 16 millimeter, but the angle of convergence and divergence should grow. So if a wider aperture would increase the angle, which leads to and also causes a shallow depth of field, then how could a larger focal length, which causes a narrower angle, create a shallower depth of field as well? I'm more than certain there's probably something I'm missing there, and when it comes to optics and physics, it's definitely a tough topic, but from the information I have, I can't seem to understand why that is. Let's see if we can find some more information on focal length and f-stop. Okay, here we go. What does the f-stop stand for? I am on expertphotography.com. To calculate the size of your aperture at a certain f-stop, you would have to divide the focal length by the fraction. For example, if you're shooting with a 200 millimeter lens, at an f4, the diameter of the aperture is 50 millimeters. So if we use this formula, as the f-stop number goes up, the opening of the lens drops.
Your aperture is controlled by an f-stop number. It's a measurement of the distance of the opening of the aperture to the edge of the inner edge of the diameter of the lens.
In this video, they're saying that if you think of the aperture is controlled by blades, right? As it opens, the blades kind of open up. And so you have the pupil, which has its diameter, and then you have the entire blade apparatus, and that has its own diameter. So the inner and the outer diameter. The f-stop is the distance from the inner diameter to the outer diameter. As the f-stop number drops, your aperture is opening up. So you have a lower f-stop number, that means the distance here is less. As you increase the f-stop number, the distance of the inner diameter to the outer diameter increases, and so you have a smaller pupil and a smaller aperture. But how does that work? Aperture from one lens to the other doesn't necessarily mean the same thing. It's just an indicator of a stop of light. That makes sense because a 50 millimeter lens with an f-stop of 2, your lens opening is 25 millimeters. 100 millimeters with an f-stop of 2 has an opening of 50 millimeters. So the same f-stop on two different lenses has a different opening. So if my logic is correct, then in order to get the same opening on a 50 millimeter and 100 millimeter lens, you would have to double the aperture for the 100 millimeter. So 50 millimeter lens with an f-stop of 2, you get 25 millimeters. 100 millimeter lens with an f-stop of 4 will give you a 25 millimeter opening as well. That's interesting. There must be so many ways to manipulate these things. It's crazy. Okay, so that makes sense. Let's see if we can find something about focal length. It is often misunderstood that the focal length is measured from the front or rear of the lens. In reality, it's the distance between the point of convergence in your lens and the camera sensor. Now let's see if we can find anything that explains the relation between focal length and depth of field. Okay, so exposureguide.com says the physical properties of a lens at a given focal length also affect the depth of field. Shorter depth of field lens, say 27 millimeters, focused at 5 meters, set at an f-stop of 4, has a deeper depth of field than a longer focal length, 300 millimeters, focused at 5 meters. 27 millimeters divided by 4, you have a 6 3/4 millimeter lens opening. So 300 divided by 4, you have a 75 millimeter lens opening. Okay, so you put a camera in a particular spot, looking at a subject, you put a wide angle lens on there, and then you put a telephoto lens on there at a particular f-stop, and you're going to get much more shallow depth of field with the telephoto lens at the same f-stop. If we go back to the formula, you essentially have a wider open aperture. Yeah, wider open aperture, but a wider open lens opening at the same f-stop on a more telephoto lens, on a longer focal length. But the difference between a nearly 7 millimeter lens opening and a 75 millimeter lens opening, but we can always come back to that. What we do know is that the focal length controls the angle of convergence, and so a telephoto lens will have a narrower angle of convergence, and then a wide angle lens has a wider angle of convergence. Hey, looks like that was a seamless transition, but it's future me again. I just keep wearing the same clothes. You made it to the end of episode 2. Good for you. Good for you for not having anything else better to do with your day. On the bright side, you're now just as confused about depth of field as I am. But that confusion won't last for very long. Trust me. I've seen the next episodes. But before we get to that point, in the next episode, we're finally gonna get out there and give some of these techniques a try and see what we come up with. Stick around.